Hello, my name is Henry, and in the next 5 minutes, I'll show you how to answer USMLE Step 1 questions on hypothesis testing. Let's dive right in. A clinical trial is conducted to determine the role of C-reactive protein levels as a biomarker for disease activity in patients with rheumatoid arthritis. A total of 120 participants are enrolled and divided into 3 groups based on modified sharp score of joint damage on hand radiographs. Mild damage score 0 to 10, moderate damage 11 to 30, and severe damage greater than 30. Participants' serum CRP levels are measured using high-sensitivity immunoassay. The researchers find that there is statistically significant difference in mean CRP levels among the three groups of joint damage severity. Which of the following statistical tests was most likely used to compare the study groups? So we can see a simple USMLE style question that is just trying to test our ability to choose the appropriate statistical test for hypothesis testing. Before we break it down, I'll show you how to do just that. So the first thing to know is that statistical tests are used to determine the statistical significance of an experiment outcome. That is to find if the outcome occurred by chance. However, although there are many statistical tests, they have specific use cases. So we must understand certain things to know which statistical tests to apply. The first thing to understand is the difference between dependent variables and independent variables. And I'll break it down using an example. So the dependent variable is the variable that we observe, while the independent variable is the variable that we vary, we manipulate. For example, when you're checking the mean age of pupils across classes in a school, we will vary the classes. We determine which classes we want to observe. However, we do not have any influence on the age we eventually observe. So the classes are the independent variable, and the age is the dependent variable. The next thing we must understand is the difference between categorical variables and non-categorical variables. So the non-categorical variables, also known as quantitative variables, are real numbers. They can be added, they can be subtracted. Examples are age, weight, and temperature. For example, there's a difference between my age and my friend's age. However, categorical variables are not real numbers. So you cannot find difference between my marital status and my friend's marital status. I'm married, he's single. There's not a numerical difference. One thing we also note is that it's very easy to convert quantitative variables to categorical variables by just adding groups. So for example, age is quantitative, but age group is categorical. Now let's use this algorithm to summarize how to choose appropriate statistical test. The first thing we must note is what type of dependent variable, what type of outcome variable are we investigating? And when it is quantitative, when it is a quantitative variable, then we're going to use a kind of test that compares mean, variance, or even looks at it on a linear scale. Those are things like t-test, ANOVA, correlation, and regression. In the case of two categorical, perfect. We can literally just represent them on number line and see how they correlate, how they regress. So correlation and linear regression. But when we're comparing quantitative variables across groups, we either use t-test or ANOVA. We use ANOVA when it's more than two groups, and we use t-test for when it is two groups. Now, another thing was more about t-test. There are two types. There's the paired and unpaired. We use a pair, when it is the same group of people compared at two different times. For example, the mean score in a particular test in a class on 2 different days. The same groups of people but on 2 different times, that will be paired. But we're comparing the mean test on a score across 2 different classes of pupils, would be unpaired two-sample t-test. Moving on to the other side, when your dependent variable is categorical, it's very straightforward. When you have two categorical variables, just think of chi-square for the sake of USMLE. Rarely, the answer would also be Fisher exact, but that is for small sample less than 20. However, when you're comparing categorical variable as your dependent or your outcome variable with a non-categorical variable, we can use a logistic regression. Now that we've learned how to choose the appropriate statistical test, let's break this question down. So the first thing to determine is what kind of outcome variable are we looking at? We're trying to investigate serum CRP level. You make sure you check how it is measured, because we spoke about how an outcome can be converted from categorical to non-categorical based on how it is measured. You can confirm that by when they said they found a significant difference in mean CRP levels among the different groups that were investigated. So outcome variable is quantitative. Then the independent variable, which is what we varied, the groups, although the joint severity has number returns, it was divided into 3 groups. So exactly what we just said just now is categorical. Therefore, we're comparing quantitative outcome across 3 categories. 3 categories, very important to note. So that would be analysis of variance. If it were 2 categories, it would have been two-sample t-tests. If the joint damage severity was used without categories, then we would have been comparing 2 quantitative variables. We would have used Pearson's correlation analysis. However, for the first 2 options, we had things used for 2 categorical variables. Now, Any question?